Hello guys, my name is Narayan Annamalai and I'm going to have my colleague Shiva join us later for demo. So we're going to be talking to you on the topic of moving to the cloud. We are program managers from the networking team in Azure. Yeah, I'm very happy to be here. So without further ado, here is the agenda. So I'm going to talk about some of the reasons for why moving to the cloud makes sense to host applications. And I'm going to talk about what does cloud offer with respect to the infrastructure, the virtual private network that you get to have in the cloud, and how you can leverage the scale that it has, and how easy it is the deployments are going to become. And now we'll wrap it up with a demo, like I said. So before going on to the next slide, one thing I want to kind of say is there are a lot of choices today to host or run an application, right? And most of the people, traditionally have done it through data center that are on premises, right? Let's take an example of such an application. Most applications have a web-facing front end and a database backend, right? And the web front end receives requests from the internet, and then it talks to the backend to store and retrieve data. This is a typical application, right? I mean, it's not very difficult to put this together, and it is not very difficult to stand it as well, like stand it up. But as you think about making this production ready, as you think about making it scale for a lot of other folks, then you start to think about a few of the parameters like availability and security, at the foremost. First, you can't have an application that's open to everyone. You will need to have some kind of a firewall. And second, you got to make this available. So you'll have to have some kind of a load balancing solution for this, right? Once you get into these kind of situations, then it is outside the skill set of just the developer. So if your application is running on-premise data centers, then you will have to work most likely with an IT staff or a network admin to get your firewall ruling correct, and to have load balancing set up for you. And most times it could also be through hardware devices. Configuration of these could be like time consuming, and it may be more process oriented, and it may not happen quickly. So you start there, and then there are other things then that it starts to creep up, which is if you're running it only for a few hundred users, then this may be okay. But as you think about running this for thousands of users, millions of users around the globe, then you need to worry about a lot of other things like how is it going to scale? How am I going to monitor these applications? How am I going to get diagnostics data for these? How am I going to actually define policies and have them attached to the applications, and as they scale, the policies still apply. So it becomes quite a challenge to run large-scale applications on on-premise data centers, and that's where the cloud can really help. So you can leverage the cloud's infrastructure and the off-the-shelf tools for most of these that adds value to your application or the service. So as a developer, you can just focus or just worry about how your code is working and behaving, and leave the rest of the infrastructure challenges to put to the cloud to solve. So let's take a little bit of more about some of these parameters over here. So think about scale, right? Even in cloud today, if you look at the last 5 years, the journey has been tremendous growth, right? Like if you take Azure specifically, 5 to 6 years ago, we had just hundred thousands of servers. Right now, we have millions of compute instances running on the cloud. Same for storage data. The same for data center networks. We have been seeing petabytes per second of data flowing in and out of our Azure data centers. So people are moving to the cloud, and the good reason for that is to leverage the scale and the infrastructure that it's got to offer. So that's the trend. And if you take Microsoft specifically, it's the network of Microsoft is very well spread out. I mean, we have data centers all over the world, and it's actually focused and concentrated on areas where the internet uses are the maximum. And then Microsoft's network is one of the largest in the world. So it actually connects all data centers are actually connected through private WAN network. So if you're running an application, let's say in US West, and you want to go global, and then you also have your application running on Japan or Southeast Asia or Singapore or whatnot, then the same code that you have running in US, it will be so easy to kind of replicate that and run it closer to your users who are in Southeast Asia. And if you want any communication between these deployments, it's going to happen through the private network that Microsoft has. And that's a huge advantage where the internet speed could be questionable in some of these areas. You are actually traversing through the Microsoft's private network and get the best of the latencies, and you continue to be connected, and you can serve users from different geographical locations. So that's a huge benefit. And with respect to the data center regions, Azure right now has 28 regions. With the recently announced regions in UK and Germany, there's actually more than some of our competitors put together. So how do we do all these? I mean, how is it possible for us to run such a big data center network and such a big infrastructure, and how can we keep this updated, and how can we be distributed? So that's a big challenge. So distributed networking and computing is a big challenge. And we're able to do that just because our data centers are truly software powered, or what we call as some software defined data centers. So the core of the concept here is software defined networking, and making it all software from the control plane, so the management plane, all the way to the data plane. So traditionally, the hardware systems or any system is kind of combined together for its management plane, control plane, and the data plane, right? It's a one unit. But if you look at the cloud, we have kind of separated them out as individual management plane, separate control plane, and host level data plane. So because this is already distributed, we have the flexibility to scale them independently. So to give more precise example, any function that you do to your deployments, like you want to create a virtual machine, or you want to add a firewall rule, or you want to create a new route, or you want to spin up more instances, or you want to scale them, all of these are just programmatic API calls. And that's what our management plane is. They expose all of these functions through APIs, which you can call into. And once these management plane gets this call, it then sends it to the next level, which is the control planes, which are sitting in every region. And these control plane managers or software systems convert these programmatic calls into something executable and send them to the hypervisors running on the data centers. The hypervisor has the agent sitting there listening and expecting such control plane instructions to come to it, and then it does the data plane operations individually on the hypervisor. So now you can imagine there are millions of hypervisors sitting on our data centers. So a single command of yours can go and directly deploy parallelly in multiple of your hypervisors where your software is running. So if you want to change a firewall rule, and if that has to apply to all your instances, and if your instance is running in 50 different nodes, 50 different hypervisors, the control plane operation can do all of that parallelly at the same time. So that's how we are able to achieve this scale. If we had to put hardware in between, or if we had to have process in between, this wouldn't have scaled like this. This is a truly distributed network, distributed computing platform, and that's why we are able to provide this scale. So, and taking this one step further, the use cases in how you actually can utilize is the traffic management, the global traffic management, right? So if you're somebody who's just starting out in, let's say, one of the regions, and you want to go to other regions, then you can just deploy the code to every other region, and you can have all of these function as a single unit. So you can set up traffic manager profiles by which you can serve your customers based on the closest geography, or based on health, or based on the proximity, a number of different ways by which you can define which regions should actually serve the particular customer. So these kind of tools are available to you off the shelf, and I'm talking about traffic management here. And we also have DNS services where you can natively register your vanity DNS names with Microsoft, and you would not need to go find somebody else to do this for you. So the cloud offers you all these extra off-the-shelf utilities that you will need to run your application at scale, and that's the point. The core to all of these is the virtual private network. So as you develop you may think that like all I have is a web tier and a database tier. I don't need much of a network over here. But the difference is that Azure is actually a public cloud platform, right? There are a number of different users and customers who come and use the services. So it's a large scale multi-tenant service. But what Azure really does well is that like every time a customer comes onto Azure, it creates a virtual private network for that customer, right? It's a logical isolation of the public cloud just for this customer. And after that, like any deployments the customer makes goes into this virtual network. And this is by default, you're already isolated, you're already secure. And from this virtual private network, you can have different connectivity options as well. Like you can talk back to the data, you can talk back to your on-premises, or you can talk back to the internet, or you can talk back to other deployments within this virtual network of yours. Now, and since we're talking about isolation, I also want to make a point about security, and this is really, really important because cloud providers like Microsoft are able to provide multiple layers of security for the applications running within the cloud. So if you see this, what I'm showing over here, there are, before a packet from the internet can actually hit or reach your application, it goes through several layers, starting from a default DDoS protection mechanism to an ACL layer, to a virtual network isolation, to network security groups that specifically apply to the workload, and then to possibly the VM firewall that you may have before the application can see the traffic. So these infrastructural security, network security is provided by the cloud platform like Azure, and recreating this in on-premise environments may be quite challenging and very extensive. So that's another good use case for having applications run on the cloud. I definitely want to touch upon the connectivity options because there are definitely good use cases where some workloads can't move to the cloud right away, right? It could be some sensitive data or something that is not ready to be distributed to the cloud, and that can reside on the on-premises. And Azure offers great ways to connect back to this so that you can actually have a hybrid cloud, so that it is not this or that, but it's a mix of both the public cloud and the on-premises. So we have number of connectivity options starting from the point-to-site to public site-to-site based tunneling to a private connection for that probably can apply for big large customers to directly connect to the Microsoft cloud. So these options make it easier for the applications to run in hybrid mode. So this is how a typical application deployment will look like in Azure. So the previous slide I showed you was a very simple one, but if you get to do that in Azure, you don't change much. You still keep your web stuff, you still keep your databases, but then you define a virtual network, you have load balancing done by the cloud for you, you have security done by the cloud for you through security groups, you have the on-premises connectivity done by the cloud for you. So you are leveraging all of the infrastructure the cloud provides, and you focus only on the application, and you will be able to build a very scalable, highly available application service for your customers. So now not just talking, but we want to show this actually to you in a hands-on demo. So I'm going to actually call upon Shiva to kind of do that. So it's nice talking to you.
Hi, I'm Siva Idupuganti. I'm a program manager within the Azure Networking Group. My colleague Narayan has given a very good context on how you can utilize the power of cloud to deploy and manage your applications. Today, let me try to show you how we have used the same infrastructure which Narayan has been talking about to deploy our application to cloud and manage all the infrastructure from just deploying code. So before I get into the details of the template, let me talk about how I created this. Visual Studio has great integration on how you could create a new project, which you can create a new project in the cloud template and specify you're using an Azure resource group, and it creates the files which are showing up here on your right, talking about one of them is the template, the other is the parameters. Let me go through the distinct components in the Azure Resource Manager template. In this JSON file, you see the outline here on your left. There are parameters, variables, and resources. So for my simple web application, I'm using a load balancer. It has 2 VMs in it, and all of this is set up in a virtual network because I would want to isolate my application, and I would want to have my own address space, which is totally segregated from the rest of the deployments on Azure. Here you have the definition of virtual network, which has the definition of address space, the subnets which are in part of the virtual network, and here this is a definition of a load balancer, which talks about the different load balancing rules and the custom probes I'm using and the NAT rules I've set up so that I can access my VMs through this load balancer. So all this together form the resources which are required to create the infrastructure which will support my basic web application. So once I have all the resources defined in the template, I also have to make sure there are parameters which are specified. Again, there is password up here, which wouldn't work afterwards. But once I have defined the template and the parameters, I can go create a new deployment right from Visual Studio through here. And I've already done this before, and I have an resource group already created with all the resources which I have mentioned in the template. See, you see the same virtual network here, which has all the subnets as we defined, and there is the load balancer and the VMs which are configured behind this load balancer, all of them already set up here. Now, I'll quickly show you the public IP address of this resource group, and this is the DNS name which is assigned to that public IP address. And if I just copy it, paste it up here, this is the default Apache web page which is coming from the VMs. I'm using Linux VMs behind it, behind the load balancer. So now, I just showed you how you can create a project in Visual Studio, define all the resources you need in the template, specify a few parameters, trigger a new deployment, and your resource group is all set up as you expected. Now, if you have to make any changes to this environment, this is similar to how you would make changes to your code, right? You think that you have to add new routes or maybe add few more security rules which will allow more traffic into these VMs. So let's look at an example. So here I'm showing you a recent change I did to the template where I started allowing the SQL traffic to the Linux VMs. As you might know, through the recent announcement, we are supporting the SQL Server on Linux. So I want to evaluate that. So I've set up this security rule under the NSG. This is part of the network security group definition. And I have created this new rule to allow the SQL traffic from a specific source address range and the TCP port 1433. So I've defined this. The next thing I did was check in my code from here. And once I'm done check-in, I didn't want to create a deployment every time I do a check-in. Instead, I use the Visual Studio build tasks, which I'll show you again here. So these are the build tasks which are getting triggered each time I commit my change into the repository. So I'll show you the definition of this build task. It has a simple basic step. This is again a beautiful integration of Visual Studio to support automated deployments into your resource groups whenever there are changes in your configuration. So here you see this is a Azure resource group deployment step. It is trying to deploy to a resource group in North Central region using the template which is part of the repository and the parameter file which is defined in the repository. I can override a few parameters here. This is the basic definition. I have it as part of a build step. There were several other builds which were triggered based on the changes which I've did, and I'll show you the output of one of the recent builds, and here is the output. It used the template and it updated the resource group in prod, and without me having to go to Azure portal or using any other tool, my network security group in Azure now has a new rule for allowing SQL. Well, this is all done the moment I did a check-in to this file. So like Narayan was talking about, this is the power of using the software-defined data center concepts, where you have the simplicity and flexibility of managing your infrastructure right from the similar interface on how you would manage code. This follows the same DevOps principles. If you have, you can easily revert back to a previously known good state. If you see a problem, you could follow the process of test, stage, and prod. This is what I have set up to. I have 2 build tasks set up here, one for stage, and the prod one is not an auto-triggered deployment. I actually queue it when I've completed my testing in stage. That's how I've set up my environment. Yeah, that's in a simple JSON template for my basic web application. But this is another template which has a lot more resources and a slightly complicated application architecture. This has 3 NSGs and 3 subnets for each. 3 subnets and 1 security group for each of them. It's a virtual network which has different tiers. You have the app tier, you have the backend database tier, and you have the front-end tier where you actually are receiving the web requests. So all that again is managed through the same JSON template. I have another deployment which where I triggered this, and let me show you that. Resource groups. This is the multi-tier service, and these are all the resources which we were seeing in the template. None of this something which I have configured on portal, by the way. There you go. So that is what I wanted to show you guys. Before I move ahead, I just quickly want to recap on what we discussed before. So Narayan, we touched upon the concepts of software-defined data center and how it improves and simplifies how you manage your infrastructure, which is required for your application. And then again, we went through a few integrations provided in Visual Studio on how you can simplify and to develop, deploy, and manage your infrastructure. And here you can find more links on more information on how you can configure your virtual network, or how you could author good resource manager templates. And there's the third link at the last, the quick start templates, has a huge list of sample templates which can become the starting point when you're trying to explore how you want to build your infrastructure on cloud. So hope you enjoyed moving to the cloud. Keep us posted about all your suggestions and questions. There is a lot of discussion groups in each of these pages. We hope you enjoy and move to the cloud as soon as possible. Thank you.